did in my brain is I just took out the 1,000 part of it. So I changed it to 1, 2. And then I could easily, I don't know if that's that much easier, but like if I did that in my head with Pythagorean theorem, 1 squared plus 2 squared equals 5 squared. So that's where I got the root 5 to get the hypotenuse. Or you could do it the long way with doing it Pythagorean theorem, 1,000 squared plus 2,000 squared equals c squared. It's just like your numbers can get big. So you don't have to do this. It's just like a nice little trick. But basically, you get your secant by doing hypotenuse over adjacent. You throw it into your formula, and then you do math. And then as far as like explaining it, then you do your cute little sentence. So you say, what was this even talking about? The searchlight something? Okay, so the searchlight, dropped searchlight. Thank you. There we go. goes by at a decreasing rate. The reason it's decreasing is because it's negative. Decreasing rate of 5,000 pi. So don't put the 1,000 or negative on this because why? Because you already said decreasing. So it's kind of like you're going south, going 60 miles per hour. You're not going to say negative 60 miles per hour. It's like weird. So keep it positive because you already talked about the negative with the decreasing. And then now for the units, if you get stuck, just look at what x was. What was even x? The length. What's the length again? Feet. Okay, so feet per t time was minute. Feet per minute when it is 1,000 feet from the closest point on the beach. Point on the beach. This is annoying. To the light. I'm literally rewriting the last sentence essentially, but putting in the numbers. Yeah.
And so on our quiz tomorrow, is that how we're writing our answers?
Yeah. It's basically exactly this, and they're worth like 10 points each, and then you like have to look for all the parts. Okay. Yeah, because I try to sneak some points, some pity points.
How many questions?
Yeah. I don't remember. So I have to look to see. So, okay. I feel like this is a little premature because I'm very hardcore about doing this after Thanksgiving, but that's fine. So a bright light is at the top of a 15-foot North Pole. Okay, a 5-foot tall elf walks away from the pole at a rate. At what rate is the length of his shadow changing when he's 45 feet away? Okay, so again, this isn't like the circle one or the sphere one or the cone one. You're going to have to like figure out what kind of equation we're dealing with. So you can draw the North Pole. Use your imagination. I'm going to make it like a peppermint. Look at that. It's creative, eh? There you go. There it is. And then I'm going to do a little elf. Try not to be too shocked by my artistic abilities, okay? See? Look at the little hat. That's cute. There is. That's the... We're going to go. Okay. All right. So a 5-foot tall elf. Okay, wait. I have to do the first sentence. Okay. Bright light is top 15-foot North Pole. Is 15 changing or no? No. So you can put 15 in there. 15 is not changing. That's the key that ever messes up. They put in numbers too soon. But the pole isn't like growing or something, okay? Is the elf. Okay, at this moment in time, is the elf growing? No. We're going to say it's a full-grown elf just to like, keep things how it is. Okay, so what's going on? He's walking away from the pole. He's walking away from the pole. And we're talking about a shadow. Oh gosh, so we got a shadow too. Okay, so Walking is obviously changing. So I'm going to do a W for the walking. I hate S's for shadow though. I'm going to do H. Okay. I just hate S's. They look like fives when I write them. So I'm just going to do H for shadow. It's the next letter. We'll be okay. Okay. So now I have to somehow do something with this. Okay. There's actually a couple ways to do this. 3 ways, actually. Okay, this is why I got rid of the MyMathLab for this, because they do the harder way, in my opinion. You could do this with a hardcore Pythagorean theorem and hardcore trigonometry. But I'm like, let's do it the easy way. As in, hey, someone said it. What did you say? You whispered it. Yeah, similar triangles, that's right. Yeah, you should do similar triangles. It's just easier. So, like, similar triangles would be, again, I still don't even have this formula because I'm like, okay. So then again, ELF not changing, pole not changing. That's why I can put those numbers in. W's changing, H changing. Okay, this 45 feet away, he's moving. 45 hasn't happened yet. Okay, so all this stuff, I can't put that 45 in yet because that stuff's changing still. So as far as like setting this up, I mean, I don't know. Whatever your geometry, do you remember this? So you go 15 over 5. How about I'll do height over height and then, oh, wait, that's not W. Silly goose.
Oh.
What is that? That's W plus H. Silly. What are you doing, Miss Jordan? Jeez Louise. W plus H over H. Okay, so I did a formula. Oh, I got to get all my stuff. What's the stuff in here that they gave me? I got the 15, I got the 5, I got a rate. Okay, so I have to figure out what thing that is. Walking away at a rate. So the walking is the W one, right? So that'll be dW dt equals 6. And then what length of the shadow? Okay, so that'll be dH. When he's 45 feet away from the pole, I'm assuming, right? So that'd be W is 45 is the question. Okay, so I put this one on here because similar triangles is kind of hard to remember to do it that way. Also, like, okay, we did our formula. Now we did our rates. Every variable has a rate. So that's good. So then now we would do a derivative, right? But like we have a, like, okay, maybe I can make it cuter, you know, like I could do this. Because what is this, 3? Okay. Well, right now I do quotient rule. I hate quotient rule. Quotient rule? But like, why? Why? Just like algebraically mess with that first and then make it easier on yourself. Do you know what I'm saying? So like, instead of like going full on deriv, why don't you just like mess with this a little bit? Like write 3h equals W plus H. And then why don't you just solve for W? Because then it looks even cuter. You know what I mean? Then it's like this real basic equation. It'd be 2h equals W, right? So, like, I didn't really, like, this looks all fancy, right? But I just made it look nice. Okay? And then now my derivative's like 80 billion times easier, right? Like, isn't that so much better? So now I had all my variables accounted for, so I don't have to do that cone stuff where I have to, like, do fancy things. I can just go straight into the deriv, which is, like, the best deriv ever. And I just, like, plug in the stuff. So I get 2 times dH dt. Okay, that didn't give me anything. And then dW is 6. And I didn't even need the 45. Okay, that's going to give me anxiety, but it's fine. That's it. So dH dt is 3 something. H was shadow length. So that is feet. And time was seconds. So then you would say the elf's shadow Oops, I did purple for that. The elf shadow is increasing at a rate of 3 feet per second when he or she, let's do he is, I didn't draw hair. Well, he could have hair. Okay, whatever. He is 45 feet away. So there you go. Okay. Then we got one more and then we're done. Okay. One more. This made me so mad, this question. Okay, so little backstory is this cone is on every AP like practice related rates thing I've ever seen. It's on everything. You will see this many times. Okay, so don't discredit it as too hard. This will be on like all the stuff. Okay, so this is how it's been like pounding in. We're doing the cone, you're doing the similar triangles, blah, blah, blah. And then 2022. It made me so mad. Okay, part D on their FRQ, they put on a related rates question. So already everyone's going to have a meltdown. They tell you about an ice sculpture melts in such a way that it can be modeled as a cone that maintains a conical shape as it decreases in size. Okay, the radius of the base of the cone is given by a twice differentiable function r, where r of t, this twice differentiable thing means that you can take derivatives a lot, twice. Okay, where r of t is measured in centimeters, t is measured in days. The table above gives selected values of r prime, the rate of change of the radius over this time interval. So you're like, okay, cool, chart. So like before, this wasn't on, this is on sheets of paper. Part D is like pages away. Okay, so you're turning the page. All this material is on the first page. Okay, setting the scene. So then you get to part D, the last question. The height of the cone decreases at a rate of 2 centimeters per day. At time t 3 days, the radius is 100, the height is 50. Find the rate of change in the volume of the cone with respect to time in cubic centimeters per day at time t equals 3 days. And they actually gave you the formula, which was really nice. Because sometimes they don't do that. Actually, a lot of the times they don't do that. So they actually were being a little nice. So what you do is you start with the formula because you're going to need to use it anyway. So they didn't even have to make you think for that step, which is nice. They actually just gave you the formula and you're like, oh, this dang cone. I know I'm going to have to do all the shebang, right? So here's the deal, though, is if you look at all your rates, that you're given or all your stuff, you're given the height of the cone decreases. So you're given dH dt equals 2 centimeters per day. No. Nope. Negative. Good job. Decreases. They'll try to mess with you with that. Okay, decreases. And if it's a multiple choice, of course, the positive option will be an answer. Okay, so at time t equals 3 days, the radius is 100, height is 50. Okay, that's not changing stuff. Find the rate of change in volume. Okay, so dV dt, because I want change in volume, in cubic centimeters per day at time t equals 3. So that's the question. So remember, this is on a different page, right? It's on a different page, okay? So I'm like, I knew it. They didn't give me a rate for R. You see it? I got V and I got H, so I got to do the thing. Actually, they did right here. Do you see it? They gave it to you in the chart. Isn't that a sass? So dr dt, so r prime is the other way to think about it. So dr dt, aka r prime of t, is the chart, right? So technically all my variables are accounted for, okay? So I can go straight to a deriv, okay? So if I'm going to do a deriv, do you guys see what you're going to have to do? I'm going to rewrite it as pi over 3. Does anyone see what you're going to have to do for the derivative? Product rule. Yay, you guys are doing great. Perf. Okay, so I'm going to go dv dt equals, and this is product rule. So you're going to do derivative of the first times the second plus the derivative of the second times the first. Okay, so for the derivative of the first, it's 2 pi over 3r, and then times dr dt, because you remember you're doing chain on all your variables. And then now you're going to go ham on plugging it in. Okay, so dv dt is the mystery. So dv dt is the mystery, so I'm going to keep that as a variable. And then 2 pi 3r. Shoot, what's the r? They gave me time. Time. Do you guys see it? What's the r? You have it. What is it? No. At time equals 3 days. Read the question. 100. Yes, 100. 100. You guys are saying it, I guess. Hey. Okay, dr dt. Oh, shoot. What do I do for that? Dr dt. Oh, wait, it's up there. Do you see it? At 3 days, the rate is -5. Do you see it? The sneaky sneakies. So we're going to put in -5. This was also no calculator, just FYI, this question. Okay, the height, 50, plus, I'm going to put pi over 3 out. Well, what's dH/dt? Do I have that? -2 times pi over 3. What was the radius? 100, right? Okay, so little math tricks, because we're going to have to clean this up. Okay, so this is -250. -5 times 5 is -25. Add a 0. -250. Okay, times 2 would be -500. So -500 times 100 would be -50,000, because you're just adding zeros all over 3. Oh, don't forget the pi. Okay. Okay, so -50,000. So how did I get that? This is 250 negative times 2, 500. Okay, 500 times 100 is 5 with 4 zeros. It's like real elementary math where you're counting zeros. Do you remember doing that? Okay, and then times pi all over 3. Then this one, 100 squared. You're doing 100 times 100. So you're counting zeros basically. So that's 10,000. Right? So that'd be -20,000 pi all over 3, and then you can combine them. 70,000 pi all over 3. And then you would say centimeters cubed per day. The answer. So you would say the volume of the cone, you would do your little shebang. The volume of the cone, is decreasing. What? It's decreasing? I'm shocked because it's melting. Just kidding. Not shocked. At a rate of 70,000 pi over 3 centimeters cubed per day after 3 days. There you go. There it is. So